Welcome to everyone. Today we will start power electronics subject for HAL and IOCL, and this module is dedicated to these two exams. Okay, and here we discussed most expected questions chapter wise. In today's lecture we discuss the SCR and devices related questions. First of all, we discuss the syllabus of power electronics syllabus. See, first chapter is SCR and devices. Devices like IGBT, GTO, okay, and all. Next, second chapter, which is very important, chopper. Third chapter is inverter. Then we discuss AC voltage regulator, okay, and cycloconverter also. Next, fifth chapter is rectifier, or we can say phase control rectifier. Phase control rectifier. These five topics include in the power electronics syllabus for any POC examination, and miscellaneous concept we discuss in the sixth lecture, which is what are the drives, AC drives and DC drives, and what type of question can be asked based on this topic. We discuss in the miscellaneous concept. So in the sixth lecture, we wind up complete syllabus and most expected questions based on the topics. In today's lecture, we discuss SCR and devices. First question on your screen. See. Yes, the latching current in the below circuit is 4 milliampere. The minimum width of the gate pulse required to turn on the thyristor is, okay. In this type of question, first you assume thyristor is in conducting state, or we can say thyristor make the short circuit, and find the current in the circuit, and this current equate the latching current which is given in the question, like that, and find the time, and this time is the pulse width required to turn on the SCR. See the process. When this SCR is on, then what is the circuit is converted in? This is one voltage source. This is the solution. One voltage source. What is voltage? 100 volt. 100 volt. Next, inductor. This SCR is short circuited. This circuit has become look like this. And this is the inductor value 0.1 Henry. Okay. So what is the voltage across the inductor? V equal to LDI by dt. Okay. Now V dt equal to LDI. Integrating both sides. This is V into T and this is L into I. Now V equal to 100 volt given. T is unknown, which is the pulse width required to turn on the SCR. L is the 0.1. I is 4 milliampere, I think. 4 milliampere. 4 milli means 10 to the power minus 3. Now T equal to 0.1, that is the 10 to the power 4 into 10 to the power minus 4, and this 10 to the power 2, and this is 4 into 10 to the power minus 6 second. Okay, and this 10 to the power minus 6 second is micro. So 4 microsecond is the pulse width required to turn on the SCR. This is the procedure for finding the pulse width. Okay, now see, 4 microampere is the right answer. Okay guys, see again, this is the question. Okay, this is the procedure for finding the minimum pulse width. Next, this is also given in the typing format. Next, second question. The snubber circuit is used in thyristor circuits for triggering, okay, dV dt protection, DI dt protection, phase shifting. Tell me the answer. Yes, dV by dt protection. Now here we discuss all the protection scheme of SCR. That is the agenda of our lectures. With the help of questions, we discuss the relevant things, or we can say all the concept related to particular concept. Okay, see, protection of SCR, protection of SCR. First, dV by dt means change in voltage with respect to dV by dt protection. dV by dt protection, and for this we use snubber circuit. Okay, snubber circuit. CKT means circuit. Okay, now next, dI by dt. For dI by dt protection we use series. Why we call it series? Because we connect inductor in series with the SCR. That is, we called it as series inductor, or we can say reactor. Both are same thing, reactor. Next, dV by dt, di by dt. Okay, next, high current. High current. For this we use fuse and circuit breaker. Okay, fuse and circuit breaker. Next, fifth, high voltage or over voltage. This is the over current. We write here over current or high current, both are same thing. Over current, over voltage. Over voltage, for the protection of SCR from the over voltage we use varistor. That is variable resistance. Next, thermal protection. For thermal protection we use heat sink. And for heat sink, thermal conductivity is large and thermal resistance RTH or theta is the thermal resistance is low. This is the condition of heat sink, because we know that current always try in electrical engineering, current always try to take minimum resistance path. In similar way, in mechanical engineering, or we can say in thermal engineering, heat developed in the conductor always try to take minimum thermal resistance. Okay, see, these are the explanation of protection scheme: dV by dt protection, di by dt protection, over current, over voltage, and thermal protection. And this question is related to snubber circuit is used in the thyristor circuit for dV by dt protection, means change in the voltage with respect to time. Okay, this is the snubber circuit, look like this. Okay, across SCR we connect RC circuit. Next, the most suitable device for high frequency inversion in SMPS. What is the full form of SMPS? Switch mode power supply. Switch mode power supply. Tell me the answer. Very famous question. Yes, see. Okay, this is the MOSFET. Now, here we discuss the some important things related to MOSFET. Metal oxide semiconductor field effect transistor. This is the full form. Okay, see. MOSFET is a majority carrier device. Majority carrier device. Okay. Next, majority carrier device. T on. T on means the time required to turn on the switch. Okay. T on. T on. And T off. T on means time required to turn on the switch, and T off is the time required to turn off the switch. Are negligible. Negligible. Okay. And we know that switching power loss. Switching power loss is directly proportional to T on plus T off. Hence, switching power loss is low, okay, or negligible as compared to SCR. Shreya, you are late. Okay. Now we discuss two questions, and these and remaining previous two questions, please visit and see the in recorded format. Here we discuss the next question. The most suitable devices for the high frequency inversion in SNPS is MOSFET, and we discuss the MOSFET related things which are important for our examination. MOSFET is a majority carrier device, that is T on T off are negligible, and switching power loss directly proportional to T on plus T off. Hence, switching power loss is low as compared to SCR and all. Next, it is means MOSFET. It is a unipolar and bidirectional bidirectional switch. Okay, bidirectional switch. It is a voltage controlled device. Okay. Size and weight of MOSFET is very less as compared to BJT. As compared to BJT. Okay. Next, thermal runaway is not takes place in MOSFET. In MOSFET. Tell me what is thermal runaway? Anyone know? What is the thermal runaway? Any idea, Shreya? See, beta, when we increase the temperature, then leakage current ICO increase. Due to this ICO, IC increase, and due to this power dissipation is increased, and this power dissipation further increase the temperature. This is said to be thermal runaway. Thermal runaway. Or we can say second breakdown. Second breakdown. Okay? Thermal runaway or second breakdown. Sir, but thermal runaway takes place in BJT. Nah, then how? No, beta. Here we discuss, see, thermal runaway takes place. Yes. This is the wrong. Actually, this is we write in the not takes place in the MOSFET. Yes, this is not takes place. This is actually we think right, but right mistake. Thermal runaway is not take place in MOSFET. And what is thermal runaway? This. Okay. Thermal runaway takes place in the BJT. Okay. But not in MOSFET. This is writing mistake. Please correct. Thermal runaway is not take place in MOSFET. Yes. Good. Okay. Each and every point is clear. Voltage control, majority carrier device, bidirectional device. Okay. And switching frequency is high. That is why speed is high. Okay. Next. And some important term also we discuss here. Let us see. TO. Time required. Time required by the switch to turn on. Time required by the switch to turn on. Time required by the switch to turn off. Now, first point, duty cycle. Duty cycle, or we can say total time period of the switch. Total time T on plus T off, and switching frequency F equal to 1 upon T. And these formulas we also use in the chopper circuit also. And duty cycle. Duty cycle. D or alpha equal to T on over T. Or we write as T on in terms of duty cycle dt. dt. Okay. Next. T off in terms of duty cycle. Total time minus T on equal to total time minus D into T equal to 1 minus D into T. Okay, 1 minus D into T. Fifth, T on upon T off equal to mark to space ratio. Mark to space ratio. Okay. Okay, Shreya. These are the important point also. Now, next question. See, when cathode of a thyristor is made more positive than its anode. Okay. Actually, in SCR, this is the symbol of SCR. Okay, this is the anode, and this is the cathode, and this is the gate. And this is the question related to when cathode is more positive than anode. Actually, this is the condition for the forward blocking state. And in forward blocking state, outer junction is in reverse biased and inner junction is in forward bias. So outer junction are reverse bias and central one is forward bias. Okay, this is the answer. Simple question based on the blocking state and conducting state. Okay. Next, which one of the following statement is correct? A triac is a two-terminal switch, two-terminal bilateral switch, three-terminal unilateral switch, three-terminal bidirectional switch. Tell me the answer. Very simple. Option B, two-terminal bilateral switch. No, beta. Anyone? Option D, sir, it is a semiconductor switch. Yes, option D is the right. Three-terminal bidirectional switch. And one terminal is empty, one other terminal is empty two, and third is gate. Okay, this is the explanation. Beta. A triac is a bidirectional thyristor with three terminals. When in operation, a triac is equivalent to two SCRs connected in anti-parallel. As the triac can conduct in both the direction, the terms anode and cathode are not applicable to triac. Its three terminals are usually designated as MT1, MT2, and gate. Okay, this is the explanation. Next, which one of the following is the most suitable device for a DC to DC converter? Tell me. Yes, option C is the right answer. Option C is the right answer. This is the wrong. Option C is the right answer. See, which one of the following is statement is correct? In a thyristor, the holding current IH is actually holding current is related to turning off process of the SCR, and latching current is related to turning on process of the SCR. And latching current, first option, more than the latching current IL, less than IL, equal to 0. Tell me the answer. What about holding current IH? Tell me what is the answer. Shreya? Less than the latching current. Actually, latching current is greater than the holding current. Yes. Now see, which one of the following statement is correct? For an SCR, dV by dt protection is achieved through the use of. Through the use of. Yes, B is the right answer. Actually, this is the Snever circuit. See, this is the Snever circuit. Across the SCR, we connect RC. This is the Snever circuit. For an SCR, dV by dt protection is achieved by using Snever circuit in parallel with SCR. A Snever circuit consists of resistance RS and capacitance CS in parallel with SCR. In parallel with SCR. See, this formula is very important here. Very important in power diode. A power diode is in the forward conduction mode and the forward current is now decreased. Okay. The reverse recovery time of the diode is TR and the rate of fall of the diode current is di by dt. What is the stored charge? What is the stored charge? Tell me the right answer. This formula is very important. Okay, Shreya. B answer. Okay. Very important formula. And this is the reverse recovery characteristics of power diode. And here we also find the value of IRN. Okay, IRN equal to TA di by dt. Okay, next this is the final formula. Which one of the following statement is correct in order to get best results per unit cost? The heat sink on which the thyristor are mounted are made of. But please think about this results per unit cost. It means that it is economical, must be economical. What is the material for the heat sink? Option A. Yes, good. Right answer. Right. Aluminium. Okay. Actually, we prefer the material which having the high thermal conductivity so that heat developed in the SCR or device bypass through the heat sink. If heat sink having the low thermal conductivity, then heat not bypass easily. Okay, that is why we want to make heat sink high, which having the high thermal conductivity like copper also. But here per unit cost, care about per unit cost. That is why we mark the aluminium. Okay, aluminium. Good, Shreya. Next. Heat sink are made from metal with high thermal conductivity. Copper, being a costly metal, is seldom used as a heat sink material, and aluminum is the most commonly used metal. See, a GTO, that is gate turn off thyristor, has capacity to amplify the gate current. Okay, sir, but I don't know answer in detail. Uh, which one, beta? Shreya? कौन से क्वेश्चन का आंसर बेटा बताओ, क्लियर करो. Previous one. Okay. But in the upcoming question, we discuss the how heat flow in a particular device, and what is the thermal resistance, what is the unit. Okay. Why we prefer the high thermal conductivity. Okay. That all the things we discuss in the next questions. Okay. In the previous question, only mentioned the per unit cost is minimum. That is why we prefer the less expensive material. Okay. If this is not mentioned, that is per unit cost is not mentioned in the question, then we prefer the material which having the high thermal conductivity like copper. But mention per unit cost is minimum. That is why we prefer aluminium. And in the upcoming question, we discuss the how heat flow in the given material. Write the correct answer of this question. Why it is said to be gate turn off? Because with the help of negative gate current, it will be turn off. That is the biggest difference between the GTO and SCR. SCR turn off by using auxiliary circuit, and this auxiliary circuit we said to be commutation circuit. Okay, tell me the right answer. Yeah, D is the right answer, na? Turn off when a negative current pulse is given at the gate. That is why gate turn off thyristor. A GTO is a PNPN device that can be turned on by positive gate current like the SCR. Turning on process of both the device, that is for SCR and GTO are same, but turning off process are different. Okay, and turn off by a negative gate current at its gate cathode terminal. Self turn off capability of GTO makes it the most suitable device for inverter and the chopper application. Next, which is the most suitable power device for high frequency greater than 100 kilohertz switching application? Power MOSFET, bipolar junction transistor, Schottky diode and microwave transistor. This is the simple, yeah. Tell me. Yes, power MOSFET. Power MOSFET. Okay, simple. Why power MOSFET? Because of high speed. Power MOSFET has lower switching loss. We discussed why we prefer this. So at high frequency up to 1 megahertz application, power MOSFET is the obvious choice. But at lower operating frequency less than 20 kilohertz, BJT is superior. Next, this question is very, very important here. And this is the complete concept behind the IGBT. Only remember this questions for the IGBT. All the concept we involve in this important concept. Consider the following statements in respect of IGBT. It combines the attributes of MOSFET and VGT. It has low forward voltage drop. Its switching speed is very much lower than that of MOSFET. Yes, this is correct. Okay, because MOSFET is the fastest device. Option A. Okay. Good, Shreya. Very good. Okay. It has high input impedance. Both the options are correct. Okay. This is the most important question related to IGBT. This is also correct. This is correct. So A is the right answer. Now, these are the all the key points related to IGBT. This question is also important. Matching type C. Match list 1, that is device, with list 2 monolithic construction of, and select the correct answer using the code given below the list. Triac, okay. Reverse conducting thyristor, that is RCT. Diac. Very simple. Yes, good, Shreya. Actually, triac is the symbol like 2 SCR in anti-parallel fashion, like this. This is the triac. And what is the RCT? Reverse conducting thyristor. One SCR and other is diode, like this, in anti-parallel fashion. And what about diode? Two diode are in anti-parallel, like this. This is the symbol of diode. This is the RCT. This is the triac. So option 2 thyristor in anti-parallel, that is triac, A connected to 1. Yes, this is the correct. And RCT, reverse conducting thyristor, one diode and one SCR, a thyristor and diode. Okay, B connected to 2. Diode, 2 diode. Yes. So is the right answer. Is the right answer. This is the symbol also. Okay. This is the one diode and SCR RCT, reverse conducting thyristor. This is 2 SCR. Okay. MT1, MT2 and gate 3 terminals. Okay. But here anode cathode is not mentioned because this is anode for this SCR and this anode for this SCR and this anode for this SCR. So anode cathode terminal is not mentioned here. That is why we discuss or we mention MT1, MT2 and gate 3 terminals. And this is for the diode, 2 diode in anti-parallel fashion. Next. A modern power semiconductor device that combine the characteristics of BJT and MOSFET. BJT and MOSFET, combined characteristics. Tell me the answer. IGBT, na? Combined characteristics. Next. This is the all relevant things related to IGBT. See, this question is very interesting. Very, very interesting. See, the anode current through a conducting SCR is 10 ampere. If the gate current is made 1/4, then what will be the anode current? Option C. Shreya, option C for what questions? 16? For 16? Tell me. You mark the C option is the right for the 16 previous question. Okay. Then tell me 16 question. Yes, C is the right answer for this question also. Because when SCR on, then no matter how much current is flowing in the gate circuit. Okay. That is why answer is C. Okay. Gate signal only affect the SCR on the turning on process, not the turning off. In a power circuit, this question is also important. 3 kV, 4 thyristor, each of rating this, okay, connected in series. What is the percentage series derating factor? Percentage. Okay. Please solve. we solve the question. First of all, we explain the string efficiency. String efficiency. String efficiency eta equal to total voltage, or we can say voltage across the string. Total voltage upon voltage rating of each SCR, voltage rating of each SCR into number of SCR into 100 See beta, eta equal to voltage across the string 3 kV. 3 kV means 3000 upon voltage across each string, each unit 800 volt, and 4 is the SCR into 100. Okay, now these 20 are cancel out. Okay, and 4, this is 30 into 100, 8 into 4. In 400, that is the 25. 30 into 25 divided by 8. Okay, what is 15 divided by, sorry, into 25 into 4? What is the multiplication of this? Tell me, what is the multiplication? This is the string efficiency. No, but that is not the 93.75. 93.75 percentage. This is the string efficiency actually. This is the string efficiency. What is the derating factor? Derating factor D equal to 100 minus efficiency. 100 minus efficiency is 93.75 equal to 6.25 percentage. Okay, 6.25 percentage. This is the way of solving the question. If the SCR, first of all, tell me how we or we can say why we connect the SCR in series in order to increase the voltage rating, and why we connect SCR in parallel in order to increase the current rating. Okay, if this question is related to current like that, in a power circuit of 3 kilo ampere, 4 thyristor each of rating 100, 800 ampere are connected in parallel, what is the percentage series derating factor? Then in string efficiency we use total current in the each SCR and number of SCR in the parallel operation into 100, then remaining portion are remain same. Okay, this is clear now. What is the series and parallel combination, and why we connect series in series and why we connect in parallel? What is the relation between the derating factor and efficiency? Okay, Shreya, thank you. See, the following is a unipolar device. Yes, good, Shreya. Yes, MOSFET is the right answer. Now next, a thyristor has internal power dissipation of 40 watt and is operated at an ambient temperature of this. If thermal resistance is this, the junction temperature C. Here we discuss all the things which will be discussed in the previous slide. And Shreya asked me the doubt, sir, what is the concept behind this? So we discussed all the things related to this. See, first of all, tell me, first of all here, electrical engineering. Okay. And here, thermal engineering. Thermal engineering is the part of the mechanical engineering, thermal engineering. See, beta. See, this is the electrical resistance and denoted by R. This is the terminal A and this is the terminal B of this resistance. And this is the current flowing in this particular conductor. Okay. And current flowing from potential point A to B, that is high potential at A. This is potential A and this is potential B. So what is the current here? I equal to VA minus VB, okay, upon R. Okay, or we can say high potential minus low potential upon R. This is the general discussion about the Ohm's law. Okay, this is the Ohm's law. I equal to V by R. VA minus VB is generally designated at V. Okay, so I equal to V by R. Okay, and current always flow from high voltage to low voltage. If this VA voltage is less than the VB, then this current is negative. It means current flowing from B to A. And this all things we know already because we are electrical engineer. First of all, tell me in this concept you have any doubt? Tell me, Shreya, in this concept any doubt? श्रेया, कोई प्रॉब्लम है इसमें? See here. Now this is our thermal resistance denoted by theta. And this is the A point and this is the B point. Okay. This is the temperature TA. This is the temperature TB. And here heat flow or power flow P. So P is equal to high temperature minus low temperature TA minus TB upon theta. If this theta is large, then this heat flowing is less. We can say the barrier offered by the material to the electric current is said to be electrical resistance. But barrier offered by the material to the heat or heat energy or heat power is said to be thermal resistance. Okay, this theta is the thermal resistance. And we take theta in left side and P in the denominator. Then what is the unit of theta? This is the temperature difference is in degree centigrade. And this P is in denominator. Then what? Degree centigrade per watt. See the question. Thermal resistance is in degree centigrade per watt. That is why we use the unit degree centigrade per watt. Okay. Now, in the given question, this is the junction temperature. This is the ambient temperature. And this is the theta is given 1.4 degree centigrade per watt. And what is the power here? 40 watt. And what is the ambient temperature? Ambient temperature is 20 degree centigrade. And what is the junction temperature? Ambient temperature is 20 degree centigrade. See, P equal to Tj minus TA upon theta. P is given 40, Tj is unknown and Ta is the 20 and theta is the 1.4. So Tj minus 20 equal to 1.4 into 4, 1.4 into 40. Actually, this is the 56 now. Okay. Then Tj equal to 56. Okay. 1.6. Okay. Then this is the 76 now. 76 degree centigrade. 76. 76 is not mentioned. What is the thermal resistance? Okay, 1.6. Actually, thermal resistance is 1.6. That is why this is 1.6. Okay, then Tj minus 20 equal to 64. Then Tj, that is junction temperature, equal to 64 plus 20, 84 degrees centigrade. Okay, 84 is the right answer. Now tell me, everything is clear now? Everything is clear in this question or not? Okay, beta. Okay, okay. Next, and this is the last question. See, which one of the following power semiconductor device has bidirectional current capability? Bidirectional current capability. Actually, in this question, silly mistake. This is not. This is two option is correct. Okay, triac is also bidirectional and MOSFET is also bidirectional. This is the minor mistake in this question. MOSFET also bidirectional, beta. This is the last. Which one of the following is the fastest switching device? Shreya, B option for the 21 question number. Tell me. No, beta. MOSFET. Fastest means speed is high, na? That is frequency high. And only option is MOSFET, not comparison of the MOSFET with other device. So this is our first chapter and most expected questions related to that particular chapter. In the next session, we will discuss chopper circuit. Okay.